Ever feel like you're just drowning in data? Yeah, you're not alone. So today, we're going to talk about the tool that helps data scientists turn that massive flood of info into actual, usable insight. It's a Python library, and it's called Pandas.
Okay, so let's start with a problem I think we can all get behind. We're just surrounded by this huge, overwhelming amount of data. I mean, think about it. Social media, scientific research, your company's sales numbers, it's literally everywhere. The real trick isn't getting the data anymore, right? It's figuring out what to do with it. And for the folks who have to wrangle all that data scientists, analysts, their weapon of choice by far is Python. Why? Well, it's super flexible, it's powerful, and it's got this huge, amazing community backing it up. But here's the thing. Python, all by itself, isn't quite enough. It needs a secret weapon. And that weapon is a library called Pandas. You can think of Pandas as this specialized toolkit that plugs right into Python and turns it into an absolute beast for data analysis.
Okay, so how does it actually work its magic? Let's dive in and see how Pandas manages to tame all that chaos.
Yeah, this quote really nails it. At its heart, Pandas is a free, open-source library. Its whole job is to make working with structured data, tables, spreadsheets, that kind of thing, super intuitive and efficient. It gives you the power to clean up your data, transform it, analyze it, all with just a few simple lines of code.
All right, to really get Pandas, we've got to start with the most basic building block, and that's something called a series. So picture a single column in a spreadsheet. Got it? That's basically a series. It's just a one-dimensional list of data. And the key rule here is that everything in that list has to be the same type of thing. So it's either all numbers or all text or all dates. You get the idea.
So for example, here we've got a series that shows Apple sales. You can see the values, right? 3, 2, 0, and 1. And right next to them, you've got what's called an index, 0, 1, 2, 3. That index just acts like a label for each one of those sales numbers.
Okay, so that's a series. Now, let's see how we take that simple little building block and use it to create the real powerhouse of Pandas, the data frame.
Honestly, the best way to think about a data frame, it's just a super powered spreadsheet. It looks like a table, with rows and columns, but it's got a ton of extra functionality packed under the hood. All right, here's the more technical sounding definition, but don't worry, it's pretty simple. Two-dimensional just means it has rows and columns. Size mutable means you can easily add or remove stuff. And heterogeneous, that's the really important one. It just means that different columns can hold different kinds of data. So you can have a column of text right next to a column of numbers, just like in Excel. And this is what it looks like. You've got your columns, which holds your data, and then you've got your rows, where each row is basically one record or one observation. And this simple grid, this is the foundation for pretty much all modern data analysis. So you might be wondering, how do we get from that simple series we saw a minute ago to this big, powerful data frame? How do they connect? Well, it's actually really, really simple. You just start with your individual series. So here we've got our list of Apple sales, and then we have a totally separate one for Orange sales.
Okay, now check this out. This is the cool part. You basically just stick them together. You put those two series side by side, and bam, Pandas automatically combines them into a brand new data frame. Each series just becomes a new column, and Pandas is smart enough to line everything up for you. It's awesome.
And doing this in code, it's a piece of cake. It's just 2 steps. First, you organize your data into what's called a Python dictionary. The keys, like apples and oranges here, they become your column names. Step 2, you just tell Pandas to create a data frame from it. That's it. And there you have it, a perfect, clean, organized table, all ready for you to start analyzing. And remember, what you're looking at was made with just those 2 little lines of code. It's that fast. Okay, but let's be real. In the real world, you're not usually typing out data by hand, right? No, it comes from files. And this is where Pandas becomes an absolute game changer. It can effortlessly read data directly from all the common file types. We're talking CSV files from spreadsheets, JSON from websites, you name it. And that one line of code you see there, that's where the magic happens. You can point Pandas at a massive, messy data set, like, say, a file with thousands and thousands of movies, and with that one command, read_CSV, it just pulls it all into a clean, perfect data frame for you. It does all the hard work. And it works both ways.
Once you're done, you've cleaned up the data, done your analysis, found some cool insights, you can just as easily save your work back out to a new file. Super simple commands for that too.
All right, so let's zoom out a bit. What's the big takeaway here? What makes Pandas so essential for data analysis in Python? Well, it really is like having a universal translator and a supercomputer for your data, all rolled into one. It can take these huge, messy tables and just make them manageable. It turns them into a flexible, powerful, and honestly, a surprisingly simple tool for making discoveries. And that accessibility leads to a pretty cool final thought. You know, for a long, long time, deep data analysis was something only specialists with super complex, expensive tools could do. But now, with tools like Pandas, that barrier to entry is just gone. It's lower than it has ever been. So it really makes you wonder, doesn't it? What new discoveries are just waiting out there now that anyone can dive in?